The past few days we've been looking at different kinds of math operations. So we started with adding and subtracting, then we did multiplying, and I want to move forward to go towards division. But before we jump right to that, I want to look at a key thing in the family of multiplying and dividing called reciprocals. And so right here at the top, I've defined what reciprocals are. So they're two numbers that when you multiply them together, their product is 1. And another word you might see maybe later on in another math course or in your future life as a math student, they may also call it the multiplicative inverse. And so multiplicative inverse is just another way, another word for reciprocal. Okay, and so for the property of reciprocal, it tells us that for every real number, A is just a generic letter that I use to represent any number. So for every real number A, except for 0, there's a real number 1 over A, such that when you multiply the two together, the A times 1 over A, it equals 1. And so this would be, as I started to say, a reciprocal, okay, because when you multiply these two guys together, you get 1. And I want to visit this except 0 statement right here because this is a big one that is important to us here. So it is true, and it has probably been told to you, that it is not okay. Okay, we can have this. We can have a 0, but it doesn't have a reciprocal because we cannot do this. So this situation of having something over 0 is not okay. Okay. So we can never have a 0 in the denominator. And just to review, a denominator in a fraction is the bottom part and numerator is the top of the fraction. So we can never have a 0 in the denominator. So that's why it's an exception for 0, because 0 does not have a reciprocal. Okay. And so everything else does, though. So looking at this blue box, we want to determine what number must be multiplied to get a product of 1. So looking at number 1, I have 1 over 2. So what do I have to multiply to 1 over 2 to get 1? I just flip it, okay? So instead of 1 over 2, I'm going to move this 2 up to the top, move this 1 down to the bottom, and what happens is, I'll show you here, we multiply the tops together. 1 times 2 is 2. The bottoms, 2 times 1 is 2. And we know that when we have two numbers that are on top of each other that are exactly the same, it ends up simplifying to 1. Okay, let's look at number 2. So a number that must be multiplied to 5 over 3. So here's my 5 over 3, and my goal is to get 1. So to find the reciprocal, all you do is you move this 3 up to the top, bump this 5 down to the bottom, and then we multiply across. 5 times 3 on the top is 15. 3 times 5 on the bottom is 15. Simplify it to get 1. Okay. Number 3, I end up with negative 20. So it's not a fraction this time. It's a little tricky, but I know I've told you what to do before. So if you just get a number like this and you need to make it a fraction, remember, to make any number a fraction, all you do is put it over 1. And then now we can find its reciprocal. So we bring this here to 1 goes on the top, the negative 20 moves to the bottom, so I get negative 20 over negative 20, and that gives me 1. Okay, so in number 1, remember the directions were to determine what number must be multiplied. So in number 1, it would be 2 over 1, or if you just want to say 2, that's fine. In number 2, it'd be 3 over 5. And in number 3, it'd be 1 over negative 20. Okay. And that's what happens. And those numbers that I just circled there are the reciprocals of the 1, 2, and 3 problems. Now we have this thing called the property of the reciprocal of a product, and that can be stated right here. So the property of the reciprocal of a product for any numbers a and b, again except 0 because we can't have 0, remember, on the bottom of the fractions. So for any numbers a and b except 0, you can basically split it up like this. So if you have two things being multiplied together, you just combine again, what we just talked about, multiply the tops together to get the top, multiply the bottoms together to get the bottom. And so in number 4, 5, 6, and 7, this is what we have. So for number 4, multiply the tops together. 1 times 1 is 1. Multiply the bottoms. 4 times -5 is -20. And that's all I can do with that. So that's going to be the final answer for number 4. Looking at number 5, I have 9m times 1 over 9. And so again, if it makes it a little easier, we have this 9m and it doesn't have it's not a fraction, so I want to maybe make it a fraction to make it a little easier. I'm going to go tops, 9m times 1. Anything times 1 is just itself, even though it has that m there. Okay, so anything times 1 is itself. 1 times 9 is 9 here. And can I reduce this any further with your rules of fractions? Okay. The 2 9s can cancel out, right? And all I'm left with is just an m. Let's look at number 6. So for number 6, I have -64ab. Now, this is tricky. Am I going to be adding, subtracting, or multiplying here? So I'm going to look at the parentheses, and I'm going to look directly to the left of it. Is there a plus or minus separating the b and the parenthesis? There's no plus or minus separating the b or the parenthesis, so that tells me that this is really going to be a multiply problem. So it really looks like this. Okay, and remember, the way that we can do this, if this is a little overwhelming, is to look at the numbers first. So -64 times -1/8. So I'm going to bring that over here. Okay, and that should make it a little more doable. I have put this over 1. Let's do the tops together. So -64 times -1, positive 64. 1 times 8 is 8. Can I reduce 64 and 8? 64 divided by 8 is 8. And so I've taken care of the numbers. I've simplified those guys out. And I just have this AB to multiply, so it just follows over. Okay. Since it's the only AB here, there's nothing else to multiply on the other side. It just carries over here. And last but not least, looking at number 7, I am going to be doing what with this -1 over 6? Okay. Go to the parenthesis. Is there a plus or minus to the left of it, separating the 1 over 6? There is not. Okay, so since there is not, it's a multiply, so I'm taking this guy and I'm going to distribute him in there and distribute him in there. So let's look at that. -1/6, the first one's going to be -1/6 times -24x. Let me scoot this down here. So let's make this guy over 1. We're going to go -1 times -24 is positive 24. The x has no buddy, so it just carries over. 6 times 1 is 6. Okay, let's move on before we simplify that guy. Now I'm going to go -1/6 times 6y. So -1/6 times 6y right here. And that is going to look like, put that over 1, -6y over 6. So the y has no buddy, so it just carries over. And now let's reduce if we can. So looking at this first one, 24 divided by 6 is 4. Bring that x along with it. 6y over 6 is going to give me 1, or just plain y. It doesn't matter if you guys put the 1 in front of the y or not. Usually in math we do not put the 1 in front, but if just for right now you're trying to learn, you're trying to figure things out, if it helps you to put that 1 there, go ahead and put that 1 there. I'm not going to take any points off. Just know that it's just usually not standard that you put a 1 there. So if you just see a variable that maybe looks like this, x plus y, that's really saying 1x plus 1y. We just usually don't write it. Let's look at some more examples. Maybe you can move along if you feel confident and you can just work ahead. If not, I'm going to work them out for you. And here we go. So number 1, 1/6 times negative 12. I see here I have this negative 12 and it doesn't have a fraction, so I'm going to make it a fraction. And just to clear up any confusion, when you make your own fraction like this and put it over 1, the number always goes on the top. The 1 always goes on the bottom. So if you're going to make your own fraction and put a 1, the 1 always has to be on the bottom. Okay, so essentially I have 1/6 times negative 12 over 1. Do the tops, negative 12. Do the bottoms, 6. Okay, and then if I can reduce, let's reduce. Negative 12 divided by 6 is negative 2. Number 2, let's work from left to right because I have 3 things this time, so let's work here to here. And I want to make this 1/12 over 1, right? So here we go. We are going to have 1/12 over 1 times negative 1 over 4th. And let's work this out before we bring that negative 1 over 7. So I'm going to end up with the tops, negative 1/12. 1 times 4 on the bottom is 4. And then I'm just going to trail this guy all the way down. And let's multiply the tops. Negative 1/12 times negative 1, so I'm going to just account for that negative on the top there. Positive 1/12, 4 times 7 is 28. And so 1/12 over 28 can reduce to 4, believe it or not. And of course you can use your calculator if you need some help with that, but it reduces to 4. Looking at number 13, I threw in some variables, this time the a and the t, so I have 12at times negative 1/3. If you get into a situation like that, my recommendation would be to work on the numbers first. Okay, so I'm going to turn this 12 into 12 over 1. Work on the tops. 12 times negative 1 on the top is going to give me negative 12. 1 times 3 is going to give me 3. I can reduce that negative 12 over 3 to negative 4. And I still have these guys, the at, since there's no other anything to multiply it to. I bring it down. And that's what we do there. Okay. The last one I'm going to leave for you to try on your own. And I will work on this one quickly for you so that you can check and see how you did. And so as you can see here, when these two guys cancel out, it doesn't turn into a 0. It turns into there's a 1 left over, a 1 left over. So I go 4 times 1 times n is 4n. I have a 1 on the bottom, and this 1 on the bottom is optional. If you want to leave it like that, that's okay, but this is better. This is a better answer, 4n. And there you go.